All right. Hello, everyone. We are going to be recording another video here for the review topics for these first sections in 1113 Homework 1. The next topic that I wanted to run through real quick is solving a linear inequality in one variable. An inequality is basically just two mathematical expressions that are compared using inequality signs, greater than, less than, greater than or equal to, or less than or equal to. To solve a linear inequality, you're basically going to solve this exactly like you would a linear equation. That is to say, you're going to put any term with an x on it, or whatever your variable is, on one side of the equation, and put everything else on the other side. You'll do the same thing in an inequality. You'll put any term with a variable on one side of the inequality, anything without the variable on the other. There's only one thing that you have to be careful of, except that you need to reverse your inequality symbol when you multiply or divide both sides by a negative number. Okay, so you'll pretend it's an equation, except that you're going to flip your inequality symbol if you multiply or divide both sides by a negative number. Okay, so let's try some examples here. So example number 1, we're going to solve this inequality, and it is asking us to represent our solution set in interval notation, set builder notation, and visually on a number line. Those are all different ways to write the solution. And again, I'll just kind of refresh your memory on what those look like. So let's start with number 1 here. We have fractions in this problem. Fractions make a lot of us feel kind of itchy. And so the first thing that we want to do is clear the fractions. To do that, you're going to multiply the entire thing through by your least common denominator. So let's figure out what our least common denominator would be for this problem. If you were getting the same denominator for all 3 fractions in number 1 here, what would your least common denominator be? Hopefully you said 6. You'd bring all 3 of those up to 6. And so that's our least common denominator. We're not actually going to get an LCD in all of these fractions. We're just going to multiply the whole thing through by 6. So what that means is we're going to do 6 times this whole thing. I'm going to write out basically all of the steps here. You might not need all of these steps, but I just want you to see them in case you need them. So we're going to distribute the 6 here. Everything needs to get multiplied by that 6. And I'm going to write that as 6 over 1 times x plus 1 over 3 minus 6 over 1 times 2x minus 4 over 6 is less than or equal to x over 2 times 6 over 1. So again, I'm just writing that 6 as 6 over 1 since I've got fractions involved. And now we'll just perform each of the multiplications. So this one here, I can cancel my fractions here. So the 3 and the 6, if I divide top and bottom by 3 there, that's a 1. This is a 2. So overall, I'm going to get 2 times the quantity x plus 1 here. That's how this first one simplifies. In this second multiplication here, I'm going to divide top and bottom by 6, right? 6 over 6 simplifies to 1 over 1. So it'll be minus 1 times that whole quantity, 2x minus 4. And that's all going to be less than or equal to this right product here. And I can take a 2 out of top and bottom, so I'll get a 3 on top and a 1 on the bottom. And so that is x times 3. I'm going to write that as 3x here. So we've multiplied everything here by the least common denominator, and you'll notice that clears our fractions. We don't have fractions in here anymore. So hopefully we feel less itchy, and now we can just go through and try to solve this just like we would an equation. So we'll distribute out each of these numbers. So we'll get 2x plus 1. I'm sorry, 2x plus 2. I'm going to distribute the 2. Minus 2x plus 4. I distributed that -1 to each of these. And then that's going to be less than or equal to 3x. Here on the left, we've got some like terms that we can combine. 2x minus 2x, that's 0. So these guys cancel. And we've got plus 2 and plus 4. That becomes 6 is less than or equal to 3x. Okay. So now to get x by itself, we're going to divide both sides by 3, and we'll have 2 on the left side here and an x here on the right. Because the number that we divided by was positive, we're going to keep our inequality symbol exactly the same way. So we've now solved our inequality, and we just have to figure out how to write our solution. When we are writing inequality symbols, I want you to make sure that the variable is on the left when you are trying to read these. Right now, our variable's on the right, which makes this confusing. What this inequality says is 2 is less than or equal to x. But when we're writing inequalities, or especially reading inequalities, we want the variable on the left. So I'm going to switch this. And the inequality symbol has to eat the bigger one. So since this inequality symbol here is eating the x, that's the bigger number. So when I write my inequality symbol down here, it's still going to be eating the bigger number. I didn't actually change the inequality. I just kind of wrote it in the opposite order. But both of these inequalities say the same thing. So x is greater than or equal to 2. So there's a few different ways we can write our answer. I'll start with a number line because I think that's the easiest. So if x is greater than or equal to 2 on a number line, that's going to be all the numbers equal to 2, which is a closed circle, or bigger than that, which is an arrow going to the right. In interval notation, this is the set of all numbers from 2 to infinity. So I'm going to write that as an interval of numbers like this. 2 has a closed square bracket on it that says we're going to include 2. And infinity always has an open parenthesis here because infinity is an idea, not a number. And then the last way that we're going to write this is in set builder notation. This is kind of a strange way that we write it in math sometimes. Set builder notation says the solution set to this is all x values such that x is greater than or equal to 2. So we have a number line. This guy right here is interval notation, and the guy down here is set builder notation. Okay, so that is how we solve that inequality. All right, so let's come over here to number 2. This one's going to be a little simpler. To solve this one, I'm going to start by simplifying. To start simplifying this, we're going to multiply out and distribute that 3. So we'll have -14 is less than 3m minus 21 plus 7. And I've got some like terms over here that I'll combine. So I've got -14 is less than 3m minus 14. So if I were solving this just like an equality, I would put all my variables on one side, anything without the variable on the other. I've got only one m on the right side here, so I'll move this 14 over to the other side to get anything without an m on the other side. And so -14 plus 14 is a 0 over here, and 0 is less than 3m. And now I'm going to divide both sides by that 3 here to get the m by itself. 0 divided by 3 is 0. and that's going to be less than m. Again, to interpret this, it's much easier to interpret these if you have the variable on the left. So we're just going to reverse this. I'm going to write the m over here and the 0 over here, and make sure that inequality symbol is still eating the bigger quantity. So m is greater than 0 is what this represents. So to write our solution here on a number line, it would look like anything greater than 0. That means we are not going to include 0, so I'm going to put an open circle, and anything greater than that is over here to the right. In interval notation, our interval will be all numbers starting at 0 but not including 0, going up to infinity. And in set builder notation, we'll start with our curly braces to say I'm a set, and it's going to be the set of all x values such that x is greater than 0. So that's what set builder notation looks like. I think for this problem in ALEKS, it might just actually want this inequality here as your answer. But I also wanted to remind you of what these different forms of your answer look like, because different places in ALEKS will include different forms of those answers. So I also just kind of want to refresh your memory on what those look like. All right, so the last one here is number 3. We've got some fractions in here, but we only have one. So before I clear that fraction, I'm going to move this 1 over. So I'm going to subtract that from both sides before I clear the fraction. So I'll have a -4 is less than -4/3 w here for number 3. Now I have all my w's on one side, all my numbers on the other, but this fraction is freaking me out. So I'm going to take my LCD. In this case, if I were getting a common denominator for everything in this problem, it would be 3. Again, I'm not going to actually get the common denominator. I'm just going to multiply both sides of this equation by 3. So I'm going to take this side and multiply by 3, and I'll take this side and multiply by 3. When I do that, on the left side here, I'm going to get 3 times -4 is -12. I'm multiplying by a +3, so I'm just going to leave my inequality sign exactly how it is. And to simplify here on the right, this is 3 over 1. Those 3's cancel, and I get -4w over here. Now to get w by itself, I'm going to divide both sides by -4 here. Because I'm dividing both sides by a negative number, I'm going to make a note to myself that says, hey, you got to flip your inequality symbol. So I'm just going to switch the order that goes in. Now, because we flipped it, we can go ahead and do the division. -12 divided by -4 is a +3. These guys cancel, and we have w here. Again, let's reverse this so I can make sense of this in my brain. This says w is less than or equal to 3. That's our solution. We can write it as an inequality. If we want to put it on a number line, we will include 3, so it's a closed dot, or anything less than that is over here to the left. In interval notation, this is the set of all numbers starting at -infinity, running up to 3. And we are going to include 3, so that is a closed bracket. And again, when you're writing your interval, make sure you go small on the left to large on the right. Order matters here. And then interval notation will look like the set of all x values such that x is less than or equal to 3. That's what set builder notation would look like. All right. So that was a kind of a quick review and to refresh your memory on how to solve inequalities. Let me know if you have any questions, and good luck on your homework.